All right, so now that I've shown you how to calculate the statistics on Desmos, we're going to apply that to talking about outliers. So we know what an outlier is, okay, and now you're actually going to calculate accurately if something is an outlier or not. It's important to know how to do this because we started writing in the data and statistics foldable, and then we're going to continue talking about it in the appropriate statistics foldable tomorrow. But we use different displays of data and data calculations when there is an outlier versus when there's not an outlier. Okay, so I'm on page 114 if you're in my 6th hour, and I'm on page 118 if you're in my 1st, 2nd, or 7th hour. I actually started writing these and the video got messed up, so now I'm in my 6th hour notebook. So you're next to the one that says appropriate statistics. So this should be what's there, okay? So our essential question is we're going to actually look at how to accurately calculate an outlier. Maybe not so blurry. Okay, so how do you calculate why does that look so weird? Calculate, oh well, an outlier. So we're going to title it literally calculating outliers. Your favorite handwritten notes. You better get used to because they're coming a lot next year. No more pretty foldables. Okay, so to calculate an outlier, we have 4 main steps. We're going to write the steps and then we'll go through an example together. Okay, that color looks like poop on the screen. Okay, so here we go. 1 that is totally irrelevant. Our first step is to find the interquartile range, or the IQR, which, reminder, is quartile 3 minus quartile 1. And we just went over how you find quartiles, and we're going to do an example in Desmos, but you find the quartile 3 minus the quartile 1. Then we multiply that number Okay, we multiply the IQR, that number, from number 1, by 1.5. Some mathematician decided that it was considered an outlier if it's 1.5 times bigger or 1.5 times smaller than your quartiles. Okay, so not quite sure who decided on that number, but there you go. That's the number. It's always 1.5 that we multiply by, always, okay? Our third step is to add the number to your quartile 3 and subtract that number, and the number I'm talking about is the number that you got from number 2, step 2, okay, from quartile 1. So again, we get this number here. This is our number. I'm going to just label it number, so then you kind of hopefully will see when you're looking back in your notes. We add it to our quartile 3. We subtract it from our quartile 1. And then our last step is if any data falls above or below those numbers, and that's from step 3, okay? So the numbers we got on step 3, if any of our data falls above or below those numbers, they're outliers, or it. Okay? So I'll give you a second because I know I'm talking right fast. You have to know this. This is important, okay? Especially when you start talking about appropriate statistics. All right, so let's do an example. Let's say I gave you the data set 65, 72, 75, 76, 78, 79, 79, and we'll use 82. Okay? Now, just looking at this data set, it doesn't really look like we would have an outlier, at least to me. Like when I look at this, I don't automatically think, oh my gosh, there's an outlier. But we have to, that was a really loud but, okay, but we have to now actually calculate to see if there is, okay? So I'm going to first calculate the IQR. So what I'm going to do first is I'm going to use Desmos to practice that. So step one is I'm going to find my IQR. Okay, so on Desmos, here, I'm going to add a table. And I'm going to type in my data. 65, 72, 75, 76, 78, 79, 79, and 82. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. I'm going to calculate my quartiles, and I'm going to do it right this time, not all cuckoo kachoo. Okay. I'm going to go here to my keyboard. I'm going to click functions. I'm going to scroll down, and I'm going to do quartile, not quantile, quartile. And I'm going to do X1, and I'm going to start by finding my quartile 1. So quartile 1 is 73.5. Okay, so quartile 1 is 73.5. Quartile 3, all I'm going to do is change this 1 to a 3, is 79. And my IQR is quartile 3, which we just said is 79, minus my quartile 1, which is 73.5. When I do that math, I should get 5.5. So my interquartile range is 5.5. And again, I did that. Now, the IQR you can't do on Desmos. There's no button here that says IQR. So you have to calculate them, and you actually have to subtract on your big kid self. Okay? My second step is to multiply the IQR times 1.5. So that's going to be 5.5 times 1.5. Okay? So again, it's always 1.5. That's the magic number. And when I do 1.5 times 5.5, I end up getting 8.25. So this is my magic number now, okay? Now my third step, it says, is to add that number to my quartile 3. So we're going to do quartile 3 plus 8.25. And my quartile 3 we wrote here was 79. So 79 plus 8.25, okay, which is 87.25. And then we're going to subtract 8.25 from my quartile 1. because we're finding the biggest and the lowest, the upper bound and the lower bound, basically. So quartile 1 was 73.5, and we're subtracting 8.25. And when we do that, we get 65.25. Whoops. Ignore that little dot. We'll make it part of the 5. There we go. So now I look at my data set. Do I have any data that's bigger than 87.25? No, my highest is 82. But I do have a data set, 65, that is less than 65.25, even though it's not crazy less than, but it is less than. Therefore, because of this statement right here, therefore, we'll use some big words summarizing here, 65 is an outlier. Okay? 65 is an outlier. So, on your own right now, I would like you to calculate if there are an outlier, or if there are any outliers of the following set of data. Let's do 4, 7, 9, 12, 13, 17, 25, 32, 49, and 54. Kind of a spread out data set for you. 4, 7, 9, 12, 13, 17, 25, 32, 49, 54. See if there are any outliers, and if they are, mark what they are doing this process. Do that now, and then you guys can check with the partner. Bye-bye, beautiful people.